A. Describe with reference to the structure of a DVD how stored digital data are read. Well, in a DVD you have a track, and it reads it in a spiral like that as it goes around. This is obviously much bigger, and in that track you get a series of bumps like that and pits. So you're getting that sort of situation. Please ignore my diagram, it's not very good. So you get a series like that. Now, coherent light, monochromatic coherent light in the form of a laser is shone down. Let me use, maybe it's like this is shone down. So you get a beam of it. It's shone down, and this actually moves over these bumps and these pits, and it samples at a specific rate. And when it has it that it goes over, let me just expand this a bit, where it goes over where you've got an edge, this will cause destructive interference and it will read as a 1. But if it forms over where there is no edge, something like that, then it will have constructive interference and it will read as 0. So the same down over here. So by setting it up that you're reading in the correct order these 1s and 0s, so here you would read a 1 there. By setting this up that you get your 0s and 1s, this puts it into a binary code. So you have a laser that moves over these bumps and these pits, and by seeing the constructive and destructive interference, you get your 1s and 0s. These pits are a quarter wavelength, so this is a quarter wavelength. That's important to measure. Therefore, by the time it goes there and back, it actually goes to a half wavelength difference, and therefore that causes your destructive interference. Okay, so that's not a great diagram, but hopefully that will help you to understand it. And then in B, the Blu-ray storage system uses a laser diode that emits a wavelength of 405 nanometers, whereas the older DVD system uses radiation of 650 nanometers. Explain the advantages of using a smaller wavelength. So with using the smaller wavelength of 405, obviously these pits, the pits are not so deep. So your bumps and your pits, the height of these is less. This will be a quarter of 405, so it will be something like 100 nanometers, where here these will be 150. And because of this, you can actually make these pits and these bumps and these pits, you can make them smaller. So you can make them smaller, and therefore you can fit more in, and therefore the more data can be stored. Also with this is that the difference between the trap separation can also be smaller. So your track separation can be smaller, and that's this idea here, is that as it goes around, it goes around like that, and it reads off like that. This distance here between the tracks can be made much smaller, and that's basically another reason for this, is that because the wavelength is smaller, because your wavelength is smaller, your resolution is going to be better. The resolution can be better, and therefore another thing that you can also do is you can also have, because these pits and these bumps are smaller, you can actually have more layers. Sorry, this is not, I can't write down there. There is more layers. I don't know what's wrong with this pen, it's not working. Okay, so all of those factors will lead to you being able to store more information using the system of 405 nanometers.